All right. One pattern of this semester is that we're going to be undoing the processes that we have been doing in first semester with derivatives. So we've been dealing a lot with antiderivatives, which is undoing our integrals, or undoing our derivative process, and undoing things like the power rule and our trig functions and all that kind of stuff. We'll eventually get to things like we had done implicit differentiation, and so we're going to talk about undoing that process. And so all of this to say that today, the process that we're undoing is the chain rule. So we're going to look at what happens when the derivative that we have came from the chain rule. And the process that we're going to use, the strategy that we're going to use to undo the chain rule and to think about those parts is going to be called the U substitution. And it will basically give me a way to work around having to think about the chain rule, which is going to make things easier, especially when the functions and the chain rule stuff gets more complicated. So we'll do it with easier functions first so that you see how it works, and then we'll start to ramp it up with more complicated functions as we go forward. All right, let's start with some fairly easy ones that you might even have been able to do just by looking at it. But what we're going to do is that we're going to do, it's called the U substitution because we're going to make U equal some inside function. Because remember, our chain rule is outside derivative of the inside function times derivative of the inside part. So we're going to be looking for two things when we determine this. The first thing is going to be, we're going to look for a function that's inside of another function. And that innermost function is going to usually be our U. We're going to make U that innermost function, and we're going to substitute it in so that we don't have to deal with looking at a function inside of another function. Then the derivative of that, we're going to call du, the derivative of u, is going to help us not have to think about going times derivative of the inside part, because then we will have talked about derivative of the inside part. So we'll start with a couple problems where I'm telling you what u is, and then we will talk about coming up with figuring out u. So in this one, I'm telling you that u equals 3x. Okay? And so there's my 3x that's happening inside of another function. So that's one way to figure out what u is there some function that's happening inside of another function? That's usually u. Du would be the derivative of u. And so derivative of 3x is 3. I'm going to put a dx there. 3 dx. And so then I'm going to look for what do I have kind of in my outer part? Well, I have a dx there, so I want to match this with my dx. So what I'm going to do, I don't have a 3dx, I just have a dx. So I'm going to solve this part so that I just have a dx. So I'm going to divide by 3 on both sides so that I have 1/3 du equals dx. So now, what is happening when I do this substitution? What's happening when I do this substitution is that instead of having to think about the 3x going on inside of the other function and how do I undo this chain rule, instead of 3x inside of my sign, it's just u. So instead of sine of 3x, now I have sine of u. But instead of dx, I need 1/3 du. So I'm going to put a 1/3 here, du. But the good news is that whenever I have a constant out in front, I've been saying this the last couple days and that it's going to come up. Here it is. When I have a constant out in front like this, I can just take it and bring it outside of the entire integral. So I can just take the 1/3 and not even worry about it when I'm doing the integral. So the process is really helping you just be able to think about one part of the antiderivative at a time. We're doing all the other work with the chain rule and reversing it separately from taking the antiderivative. And then all we have to worry about is what's the antiderivative of sine? Well, antiderivative of sine is negative cosine. Plus c. And so that's going to equal negative 1/3 times the cosine of, now we're going to take and put it back in so that we have it in terms of x again instead of in terms of u. Cosine of 3x plus c. So we'll put our inside function back in again now that we don't have the chain rule to worry about and think about. Now, again, you might be thinking, I could have probably come up with the fact that the 1/3 came out in front. Like some of you might be able to do that pretty easily and think about it in a pretty easy way. So let me, before we do the next problem, let me jump to a problem where, number one, it's more clear what u is, and number two, it's more useful in making an antiderivative easier to take so that you can see why we might do this process for a more complicated problem. So let's jump down to part B over here. So I want to know what u is, and I want to know what du is. And this time it doesn't give it to us. Last time it just told us here's what u is. But most of the time you're going to have to figure that out yourself. And the way that we're going to do that is that you should be looking for two different things when you try and figure out what u is. Number one, you should look for u by a function happening inside of another function. And number two, you should be looking for du, in other words, the derivative of what you think u might be, to maybe be somewhere else in the problem. And both of those are happening here. And so I will tell you, hopefully some of you might have spotted it, but u here is going to be tangent of x. Two clues that that's going to be u. Clue number one, tangent is inside of another function. It's inside of the square root. So when we talk about the chain rule being outside derivative of the inside function times derivative of the inside part, then there is that inside function. We want u to be that inside function, and then du to be factoring in that times derivative of the inside part for us. And so du, here's clue number two, that u should be tangent. That du, we want to look for it to be somewhere else in the problem. And would you look at that, derivative of tangent is secant squared. And by a remarkable coincidence, secant squared x dx is already somewhere else in the problem. And tangent is happening inside of that square root. And so this matches with this. And so here come my substitutions. I still have a square root. But instead of square root of tangent of x, instead of thinking about a trig function inside of a square root, I can just replace tangent of x with u. And then, even better, instead of having to factor in this secant squared of x dx, all of that, well, that matches completely with du. And so I can just put du. And now, that's a much, much easier antiderivative to take. So antiderivative here is going to be, well, we have, this is u to the 1/2, and so if I were to add one back, it had to start at u to the 3/2. But there was no constant out in front, so to cancel out the 3/2 that would hop out in front, I need a 2/3 there. And so now to end of this part of the process, we're going to put u back in. We're going to put it back in terms of x. To get our final answer. So instead of u, we're going to put it back to tangent of x. Plus c. And you can double check. You can take this derivative back and verify that we would have this 3/2 come out in front and cancel. And then I would have tangent of x to the negative 1/2, or to the positive 1/2, sorry, to the 1/2, which would make it be the square root of tangent of x. And then we need the chain rule, times derivative of the inside part, derivative of tangent of secant squared. So in these more complicated problems where we're looking for what u is, we're going to look for, number one, do I have a function happening inside another function? Number two is the derivative of what I think u should be. Is that derivative somewhere else in the problem? Number one is usually going to be more useful, the function happening inside of the other function. So let me go back up here. And we're going to have a similar thing happening on part B here. Is that it tells us that u is 2x. How would I know to make u 2x? Because 2x is happening inside of other functions. In this case, it's happening inside of both secant x, or of secant and tangent. Is secant and tangent of 2x. So instead of having to think about undoing that 2x and that chain rule, let's do that separately from taking the antiderivative. That's what u substitution says. Is to undo that process separately from thinking about the antiderivative rule. So u is 2x, then du, derivative of 2x is 2, and we'll put a dx there. So we're putting a dx here because our the phrasing of our integral has a dx there. Usually we would divide this by dx and write it as du over dx. And that would be our usual notation. But in this case, it's going to be more helpful to leave the dx over here so that we know to substitute it in for the dx. So let's see what we have here. Let's make my du match with what we actually have, because I don't have a 2dx. I just have a dx. So let's divide by 2. So then I know what dx is, since that's what's in my integral. 1/2 du. All right, so instead of 2x, u is 2x, so I can just put u in here. And then that's now in terms of u, so du. And then I had a 1/2 that was a constant, so it's coming out in front here, which means also that it can come out in front of the entire integral. So 1/2 can come out in front of the whole thing. So antiderivative here, put it in green so it's clearer. Antiderivative of secant tangent. Well, secant in tangent, that's the derivative of secant. Secant of u, but I'm going to put my answer back in terms of x instead of in terms of u. So that will equal 1/2 secant of, instead of u, we're going to put 2x. Plus c. Let's do one more here. So once again, I need to choose u. And the clearest way to choose this time is that, once again, there's a function that is trapped inside of another function. So that function that's stuck inside of another function is what we should make u. And that is my 1 minus x. Because it's inside being squared. So u is 1 minus x. And du will be, derivative of 1 is 0. Derivative of negative x is going to be negative 1, so negative dx. But I don't have a negative dx. I have dx. I want to know what dx is. So dx is negative du. All right, I divide by negative 1. I'm making it match what I have up here in my actual integral setup. So that I know what to substitute dx for. I know to substitute dx for negative du. I'm going to go ahead and put du out over here because I think that's easier to visualize and to work with it. And then I have a negative. I can bring it out in front. Because that's just a negative 1. I can bring that out in front. And then I have a 1 on top here, since I put the du out over here. Right, it's 1 times du. And instead of the 1 minus x being squared, I substituted the 1 minus x for u. So now all I have is the antiderivative of 1 over u squared, which is a bit easier of an antiderivative to think about. Now I don't have to balance, well, what happens with this 1 minus x, because I've already dealt with it by doing this u and du process. Sorry, this negative is here. I have to make it blue. Negative. Antiderivative of 1 over u squared, that's going to be u to the negative second. So that means there had to be a negative first here to start with. Well, there's a positive 1 over u squared, and so there had to be a negative to counteract it. And so when I go to substitute my u back in at the end of the process, this is a negative negative, so this is going to be a positive. And it's going to be 1 over u, which was 1 minus x, plus c. And here's the answer to this one. So again, this is what we're going to spend the next probably 3 to 4 days of notes going over. We're going to do a whole bunch of these. You're going to have about 3 different worksheets that are going to practice these. Just like all our other antiderivative stuff, the more you do them, the better we're going to get. And hopefully by the end of the next couple days, you're going to start to see the patterns for what we make u and what we make du. And a lot of that will start to click together.